ion implantation technique, this energy is provided in the form of kinetic energy. Okay, so a beam of dopant with a high kinetic energy is projected uh, over the substrate, and then it diffuses inside the substrate. So we will see how it happens. It requires a particular ion implantation system which has an ion source, as you can see. These ions are generated by striking an arc discharge in the gas, and they are earlier a divergent beam of ions is formed because they repel each other and they start moving out of the source. So we require a set of electrical lenses to have a focused beam of these ions. So these ion beam will then enter a mass separator which has a very strong magnetic field, and the purpose of this mass separator is to direct only the desired iron dopant species through the aperture of these lenses. So heavier ions and lighter ions, they are split away, and only the desired ions will enter this aperture. And to maintain the focus of the beam, the second set of electrical lenses is used. Then to impart a sufficient kinetic energy to this ion beam, a set of accelerator is used, and we can deflect this beam over the surface of the wafer in x and y direction using these x and y deflection plates. So you can see that here. So what are the properties of these ion implantation system? That it depends, it is not the thermal energy which is imparted to the impurity, but it is based on the principle of kinetic energy. The first point is this. Then based on what kinetic energy has been imparted, there is some projected range, and it is in terms of micrometer. Okay. So around the typical range is generally, penetration range is around 0.1 micrometer to 1 micrometer range, and the profile or the impurity profile which is achieved by this method is a Gaussian impurity profile, which we discussed in the last lecture. And we can perform several implantation at different energies, and we can get a junction with varied profiles by varying the kinetic energy of the ions. This is the profile which is achieved. You can see that x-axis is the distance and rp is the projected range. That is, the ion will actually uh, have some projected range inside the substrate where the concentration will be maximum. But of course, from that maxima, the concentration will decrease as we move away from the projected range. Okay, so it will have a maximum peak at certain point, and there will be variation in this in a Gaussian profile manner as we move away from this distance. So what happens is that ion implantation requires another method known as annealing after it, because when very high kinetic energy impurity it is projected over the substrate, actually it damages the surface of the silicon, and now it doesn't have any longer have a crystalline structure. So to achieve that well ordered crystalline structure back, annealing is the process which is taken care of, and this is done at at around 1000 degrees Celsius for about 30 minutes. Okay. The another way of annealing can be using a laser beam, or electron beam annealing can also be used. You can also see that during this annealing process, we achieved a maximum diffusion profile at certain. It does have certain advantages over diffusion, that as compared to the diffusion profile, ion implantation junctions are more precise and well controlled because we can actually control the dopant density well in this furnace. Okay, lateral diffusion is very less, so that is another advantage. The quantity of dopant can also be controlled here. Okay, so it is particularly in VLSI technology, ion implantation is preferred because we can achieve a junction of order of the range of order of around zero point 0.1 micrometer in this case, whereas it was quite higher in case of diffusion. Okay. So, because it is more precise, you have well control over the process, but all this requires a particular ion implantation system, which is much costlier as compared to a diffusion system. So, this process is precise, it happens at low temperature. Uh, it happens at low temperature also has an advantage that the previously doped regions are not affected by this process. So it doesn't have any secondary effect. Okay, but the process is costly as compared to the diffusion process.